System design interviews can be daunting. They test your ability to design scalable, efficient, and robust systems. This 4-week plan will equip you with the knowledge and confidence to ace these interviews. Each week focuses on a different aspect of system design. We'll start with foundational concepts and gradually move towards more complex scenarios and interview practice. This guide is designed to be beginner-friendly. We'll use clear language and practical examples. Get ready to dive in and learn the key principles of system design. By the end of this plan, you'll be well prepared to tackle your system design interviews with confidence. Let's get started. This week is all about building a strong foundation. We will delve into the essential components that form the backbone of modern web systems. You'll learn essential system design terminologies and concepts that are crucial for any aspiring developer or system architect. Focus on understanding terms like CDN, DNS, load balancers, and RESTful APIs. These terms might seem complex at first, but they are the building blocks of efficient and scalable web systems. These are fundamental building blocks of modern web systems. Without a solid grasp of these concepts, it's challenging to design systems that are both robust and scalable. Start by understanding how CDNs work to deliver content faster. CDNs, or content delivery networks, are essential for reducing latency and improving user experience by delivering content from the nearest server. Then explore the role of DNS in resolving domain names to IP addresses. DNS, or Domain Name System, is like the phone book of the internet, translating human-friendly domain names into IP addresses that computers use to identify each other on the network. Learn how load balancers distribute traffic across multiple servers to prevent overload. Load balancers ensure that no single server bears too much traffic, which helps in maintaining the performance and reliability of your web applications. Next, dive into the world of APIs. APIs, or Application Programming Interfaces, allow different software systems to communicate with each other, enabling the integration of various services and functionalities. Focus on RESTful APIs, a popular architectural style for web services. RESTful APIs use standard HTTP methods and are stateless, making them simple and scalable. Understand how REST uses HTTP methods: get, post, put, delete, for communication. Each method serves a specific purpose, such as retrieving data, submitting data, updating data, or deleting data. Explore the difference between RESTful APIs and WebSockets, another communication protocol commonly used for real-time applications. While RESTful APIs are great for many use cases, WebSockets provide a persistent connection for real-time data exchange. Finally, grasp the basics of caching. Caching is a technique used to store copies of files or data in a temporary storage location to reduce access time and server load. Learn about different caching strategies like browser caching, CDN caching, and server-side caching. Each strategy has its own advantages and use cases, helping to improve the performance and efficiency of web applications. Understand how caching improves performance and reduces server load. By storing frequently accessed data closer to the user, caching can significantly speed up response times and reduce the burden on your servers. By the end of this week, you'll have a solid understanding of these core concepts, setting the stage for the next level. This foundational knowledge will empower you to design and build more efficient, scalable, and reliable web systems. Building upon Week 1's foundation, we'll now delve into more advanced concepts. This journey will take us through the intricate layers of system design, where we will uncover the complexities and subtleties that make robust and scalable systems possible. This week is about broadening your knowledge and understanding the nuances of different technologies. We will explore how these technologies interact and complement each other to create efficient and reliable systems. You'll explore concepts like databases, consistency, and availability. These are the pillars of any data-driven application, and understanding them is crucial for designing systems that can handle real-world demands. Begin by understanding the difference between SQL and NoSQL databases. SQL databases are structured and use predefined schemas, making them ideal for complex queries and transactions. NoSQL databases, on the other hand, offer flexibility and scalability, catering to unstructured data and high-velocity applications. Learn when to use each type based on your application's needs. For instance, SQL databases are often used in financial systems where data integrity is paramount, while NoSQL databases are preferred for social media platforms that require rapid data retrieval and storage. Dive deeper into specific NoSQL database types like key-value stores, document databases, and graph databases. Each type has its unique use cases and advantages. Key-value stores are great for caching and session management. Document databases excel in content management systems, and graph databases are perfect for applications involving complex relationships like social networks. Explore their strengths and weaknesses. Understanding these will help you make informed decisions when architecting your systems, ensuring that you choose the right tool for the right job. Next, understand the CAP theorem. This fundamental principle in distributed systems design highlights the trade-offs that must be made when building distributed databases. This theorem states that it's impossible for a distributed system to simultaneously provide all three of consistency, availability, and partition tolerance. You must prioritize based on your system's requirements and constraints. Learn how different systems prioritize these aspects based on their requirements. For example, some systems may prioritize availability over consistency to ensure that the system remains operational even during network partitions. Research concepts like distributed consensus and how it's achieved in systems like distributed databases. Consensus algorithms are essential for ensuring that all nodes in a distributed system agree on the same data, which is critical for maintaining consistency. Familiarize yourself with common architectural patterns like microservices and message queues. Microservices allow for modular and scalable system design, while message queues facilitate communication and data exchange between different parts of the system. By the end of this week, you'll have a deeper understanding of system design principles and trade-offs. You'll be equipped with the knowledge to design systems that are not only functional but also scalable, reliable, and efficient, ready to tackle real-world challenges. Practical application: designing real-world systems. This is where the rubber meets the road and you get to apply all the theoretical knowledge you've accumulated so far. This week, you'll apply your knowledge to design real-world systems. It's an exciting opportunity to see how your understanding translates into practical solutions. We'll move from theory to practice, tackling specific design problems. Don't worry about time constraints just yet. Focus on working through the problem from start to finish. Start by working through some classic system design problems. Choose problems that interest you, like designing a URL shortener, a social media feed, or a ride-sharing app. Selecting problems that you are passionate about will make the learning process more engaging and enjoyable. As you work through each problem, focus on breaking down the problem into smaller components. Identify key features, estimate the scale, and consider constraints. This methodical approach will help you manage complexity and develop robust solutions. For each problem, research real-world implementations. Understanding how existing systems work can provide valuable insights and inspiration for your designs. Look at how companies like Twitter, Instagram, and other tech giants have approached similar challenges. Their solutions can serve as a benchmark for your own designs. Learn from their design choices and understand the reasoning behind them. This will help solidify your understanding and give you practical insights into how these systems are built. Analyzing their approaches can also help you understand the trade-offs and optimize decisions involved in your own designs. As you work, document your design choices and the rationale behind them. Clear documentation is essential for communicating your ideas and ensuring that others can understand and build upon your work. This week is about turning your theoretical knowledge into practical design skills. Embrace the challenge. The more you practice, the more proficient you will become. Polish and refinement: mastering the interview process. The final week is dedicated to refining your approach and practice under time pressure. Practice is crucial for success in system design interviews. Find a study partner or join online platforms that offer mock interviews. During mock interviews, simulate the real interview environment as closely as possible. Use a whiteboard or online collaborative tools to sketch out your designs. Practice explaining your thought process clearly and concisely. After each mock interview, reflect on your performance. Identify areas for improvement, whether it's clarifying your explanations, handling ambiguity, or optimizing your design. Continue refining your approach based on feedback and self-reflection. This week is about building confidence and mastering the art of communicating your design thinking effectively. Section 6: Conclusion Confidence for Interview Day and Beyond. Congratulations on completing this 4-week system design interview prep plan. You've gained valuable knowledge, applied it to real-world problems, and practiced your interview skills. Now, it's time to approach your interviews with confidence. Remember to relax, breathe, and trust in your preparation. System design is an iterative process. Don't be afraid to ask clarifying questions, discuss trade-offs, and iterate on your design based on feedback. This 4-week plan is just the beginning of your system design journey. The field is constantly evolving, so embrace continuous learning. Explore advanced topics like distributed systems, microservices, architecture, and cloud-native design. Stay curious, keep practicing, and you'll excel in the world of system design. If you found this video helpful, don't forget to subscribe for more content. In upcoming videos, I'll be diving into core system design concepts and walking through popular design topics in detail, like Instagram, Dropbox, and Ticketmaster. Stay tuned, and good luck with your interview preparation.